passionate conversation. I'm a person who does not know a lot or anything about quantum AI as a thing, quantum computing as well as AI. And I'm just your student in this case, trying to learn more and more from you about what you're doing, how your career trajectory has been, the kind of implications quantum computing has in AI, and a lot of other things. And then we'll deep dive maybe within one or two of the subjects as we move, in the conversation, so that we can provide actionable as well as learnable insights for the readers and the viewers. So that's how this will go. So any general question that you have before we move?
Okay. I think that makes sense. Sounds exciting as well, and thanks for the opportunity to talk to you in general. So I think in terms of my background, though, it was in quantum mechanics. So I did my master's in physics, basic sciences, bachelor's physics from Indian Institute of Science Education and Research, and then I came to UK for a PhD in theoretical quantum physics. It got too abstract when I was about to finish my PhD. It got too abstract. So I was happy solving the problems, but it was mathematics, I couldn't see a real world impact on that. So that's when I switched to AI. So I like studied for like 1 or 3 months. I was already strong in maths because of physics background. So the switch was easy. And since then, been working in machine learning, data science, AI space. In terms of, I think you mentioned some key terms which I might not know the answer to. So, like quantum machine learning and others. I'm not actively exploring those fields currently. I think yes, that might be the one of the correction because you might have some questions related to that.
Like I said, right? In the field, and I think this is a, I would say, a recurring theme, not just with me but like a lot of folks in the industry when they hear two very distinct terms, right? When it comes to AI and when they come to quantum computing, they sort of this mismatch and say that okay, this might also mean this might also mean that. And I
Yeah.
mean, you actually started off with a very nice topic which I want to first deep dive into, which is your career journey, your career journey and your transition. So you
Okay.
studied theoretical physics, is that correct?
Yes. Yes.
Yes.
So yeah, so I'm from Rajasthan. I got admission in IIT, but I also gave another competitive exam, which is KVPY. And
Okay.
so I got two options. Either I go into science with KVPY or I go into engineering with IIT. And generally, I'm very curious. So I thought, oh, okay, everyone is going to IIT. A lot of my friends have as well. So I'll try to see what I can do in the other space. So I did that. And so that was a BS plus MS from Indian Institute of Science Education and Research. They were quite new at that time. Um, and then we had it was based on the way they do masters globally as well. So I got opportunity to do internship in UK as part of my masters. I was able to publish a paper during my masters as well, and so that was very fun. And then we didn't have placements. In that, oh, you're doing science. Why do you need placements? So I thought, oh, okay, let's do PhD. It sounds fun. I get to travel the world as well. So I came to UK for PhD in theoretical quantum mechanics, and that was very nice. So I get to meet a lot of very intelligent people, get to learn a lot. And so I think the first few years were pretty nice. So I was helping as a theoretical advisor to another experimental group, and we were able to publish few papers. And then I got a lot of freedom in terms of choosing what projects to work on. So I spent like 1.5 years trying to figure out what problem to solve, and that was a very frustrating experience. I was able to do it, and I published another paper, but by that time I've kind of lost interest. Oh, this is too abstract. I want to do something that is more real. So that's when I started with Andrew Ng's machine learning course. Picked up Python by building few random games in general, um, and so on.
So why don't you tell me about this? I'm assuming there have been a certain number of parallels between your studying and your learning from the quantum side of things. I'll just call them that. And at the same
Yeah,
time, what you're doing in machine learning today. So
yeah.
why don't you talk more about as a, I was as a kid, as a senior researcher, who is currently in your path, like in your shoes, what you were 20 years ago, and who is learning more about quantum computing today, what kind of parallels do you see for those people? And what kind of
Okay.
parallels have helped you in that case?
So I think there are a few things. So some are technical things and some are soft skills as well. So if you're doing a PhD or if you're doing research, generally you need to ask the right question. It takes a lot of time. So you need to define what problem you want to solve rather than, okay, I have a tool, where do I put this tool in so that I can solve anything, right? So it's very important for you to like do great amount of review, come up with the problem worth solving, and then you start thinking about, okay, how do I solve the problem? So this whole process of problem solving and coming up with creative solutions, because you don't want to repeat something that someone has already done. You want to make a dent, like, oh, this is something new that no one in the world has ever done. So you get like you you get to be more creative in terms of how you want to solve a particular problem, and your overall skill set in solving any kind of problem improves. In terms of technical parallel between theoretical physics in general, or like quantum mechanics, as well as AI machine learning, both requires multivariable calculus if you want to deep dive into. If let's say someone asks you to, oh, okay, how does that propagation work? So everyone can explain it. If someone asks you to derive how it actually works and what are the improvements you want to make from there, because then you need a good amount of mathematical background. It's not too much, but like it's more in physics. It's so much less in AI. So if you are already doing theoretical physics, you have taken, let's say, even courses in statistical physics, etc. So you're good at probability. You're good at statistics in general. These things become very easy to pick up as well, depending on niche. And then you are good enough at multivariable calculus. So basically, deep learning becomes very easy to pick up. Programming remains a challenge, so an effort would be to spend more time focusing on computer science or software engineering than, because picking up algorithms, writing them from scratch, etc., is much easier.
I don't know, like on a similar quote, right? Since you have been in this field for such a long time, I assume almost 14 years, if I'm correct. Like I have stalked you
Not
correctly
really,
on LinkedIn.
not really.
I
No.
mean, I mean the computing, the quantum computing side of things, right? Where you started your
Yeah,
learning journey. Yeah.
yeah. Since 2009, so
Yeah.
2009 to 18 was quantum and like general physics, and then 2018 to 25 is AI, ML, data science.
Hmm. So that change that you mentioned, right? And obviously you mentioned that there are a certain number of panels between the two. But how has a change, and I would call it a career change, right? A career transition that you've had. Uh,
Yeah,
how has the journey been for you? Because I think a lot of professionals, even in today's day and age, they fear
yeah,
this, right? Like a lot of marketers still want to remain the traditional marketers that they call it. Like they don't want to become an AI marketer. A lot of
yeah.
companies still want to stay the traditional old companies and don't want to adopt new tech. So how has the transition been for you, and how has the entire transition of adopting something new that feels more real has been to you?
I think that's a great question. I'll need to think about it a bit. So I think first of all, the decision to make the transition was difficult because I've already spent so much time, like, like one third of my life, studying physics. So of course, I think that was very much that. Yeah, I was dreading that decision. That's why like I made that switch like, right at the end of my PhD. Like, okay, I do want to finish it properly, and let me see if I can do a postdoc or anything. So I think the most important thing is making a decision. In general, once you made the decision, the path is quite easy. I would say. So if you have decided something, okay, this is what I want to do currently, then I think everyone knows what to do. So if you ask anyone, they would be able to come like within a day, they would be able to come with an answer. Okay, I want to be an AI researcher. So this is the path that I should follow. These are the people I should follow because there's so much information on the web. And you can learn from other people's journey. Where it fails for many people might be because of lack of discipline, maybe. So like I know how to lose weight, but I can't because I'm not disciplined enough. Um,
Hmm.
kind of general, I think, yeah, taking a decision was the most difficult task for me. Obviously, then to learn a completely new thing, even though they share a basic set of skills, we're still quite new because it's a different way of thinking. So in physics, we are like, you need to solve this problem properly, deterministically. You need to write down the differential equations, solve them, and see how it works. In machine learning, it's like throw some data and see what comes out. So it's more of an engineering kind of a mindset. I think that change was slightly difficult as well. And you learn a lot once you start doing these projects. And then getting a job is slightly trickier as well because you don't have a background where you're applying. So I think in my case, thankfully, I had a PhD, so people took notice of the CV, like, oh, okay, he has done a PhD, so we can at least call him for an interview or something, and that helped. And I was able to draw this parallel in the CV as well. But it could be difficult for some people. But a lot of the leading AI researchers, well, I can't remember the name, like they came from studying from humanities, social sciences, like not everyone has done a PhD in AI. Like right from the beginning, they have not been like in AI from the beginning. They slowly switched to it. So someone studying in humanities, then they came up with a talk with Dr. Hinton. They attended the talk and they're like, oh, okay, yeah, this looks pretty cool. Let me explore that. And then slowly they make it. Yeah, I think switching is easy decision. Because,
You're very good point, right? I think most of the folks who leading the space in AI are not actually some of the AI researchers or like have their PhDs or have dedicated their lives in it, but are rather
yeah,
the folks who are exploring the right use cases in these industries,
yeah,
right? And I mean that's an interesting panel because what I have seen, I mean from my side of the story, right? Most of the folks who are acing in the B2B SaaS space, like
mhm,
building these AI SaaS products, are actually not builders or engineers, but actually designers and folks who never had access to build. And I think that's the idea,
yeah,
right? Like AI has a more philosophical approach to it rather than a more engineer approach as well. So
yeah,
it's an interesting space, definitely. I agree with you. But yeah, sure. Based on like things that I've been researching, because I'll be very honest, the topic of this podcast was terrifying for me when I saw both computing and AI and responsible organization. There's a lot of things going on, right? But I want to firstly discuss with you, since we are from both sides of the field, there's always this notion that better computing will unlock faster results, especially when it comes to AI computational power, right?
mhm,
Now,
yeah,
when we talk about the myriads of, I would say, advancements that, for example, Microsoft has made, especially with quantum computing chips, where do you think the industry is headed, both in terms of the quantum computing side of things and then the AI improvement side of things? Like, that bell curve, what will happen? Like, will it come down? Will it be like, will it exponentially up? What do you think? Like, where do you think you're headed?
yeah. I think that's a great question again. So there are a lot of companies that are working on building these quantum computers, and so like Microsoft, IBM, D-Wave, and some other research labs as well. They are able to make very like quite big quantum computers using say 100 qubits or 1100 qubits or so on.
Yes.
And qubit is just a unit like
Quantum bit, right?
uh,
Like, it has a matrix sort of a system of 0 to 1. Yeah.
yeah, yeah. So in classical computing, we have zero or one. In qubit, you have zero plus one divided by two. As a like a very simplistic example, it's just a superposition of both. So at any particular point in time, you are in both states. But as soon as you measure it, you are in one of the state, right? So as soon as you go in and measure, okay, which state am I in? You are either in zero or one. You're not in both. It's kind of like Schrodinger's cat. Like if there's a cat under a box, it's bad. Like, you don't know till you actually see it, right? Um, so yes, I think there are quite a lot of companies building these computers. There are quite a lot of researchers doing great research. There are a lot of algorithms that have been developed already, like 50 years, 30 years ago, that show theoretically, like, okay, given a quantum computer, we would be able to perform much better search than any of the classical algorithm. Given we have a quantum computer, we would be able to break any sort of encryption brute force.
Yes, yes. I've seen that part. Yeah.
Yeah, because it's just so computationally efficient in general. Now, and there are a lot of papers from, let's say, Google, IBM, Microsoft as well. Oh, we have reached quantum supremacy, etc. At this point in time, most of it is hype. Because they show something like, okay, we have done a calculation that will take
A normal computer like 52 billion years, something like that. Yeah.
yeah, exactly. Yeah, but there is no practical use first. And second, apart from the last paper that maybe Google released, everything else, someone within a year or within 6 months, someone has built a classical algorithm that does that in a very similar amount of time. So I know like they're pushing the boundaries and they're building things up, but I think quantum computing has a long way to go. And same with artificial general intelligence. So we do call like generative AI as AI currently, but if we do talk about general intelligence, and that has a long way to go as well. So in terms of marrying both of them, I think given that the current systems are very data hungry, uh, and the way generally I share like Francois Chollet's view on general intelligence, which is more to do with skill acquisition efficiency. So it's not about scroll the whole internet, remember it, and then I know a lot of things. That's a bread. It's more about how quickly you grasp new content, and then how quickly you make generalization content. So as a person, I've only probably read like 200, 300 books my whole life, including school books as well. As an AI model, I have read like 14 trillion tokens already, and I still struggle to reverse the string. So it's like I won't. I think in terms of that's my view on AGI or AI in general. For quantum computing, a lot of it is hype. A lot of the cool research is happening. Most of it has been theoretical. There have been few papers where people showed like, oh, we have built a superconductor at room temperature, but then when it goes through peer review, it generally fails. So I'm not sure like how like I would say like quantum computing is like still like 20, 30 years. It will
Yes.
it will take that much for it to make an impact. Um, and in terms of parallel between both, yes, I think if we can, if we do have a quantum computer and we have better algorithms, or maybe the same, I think maybe transformers will work as well. And I think that would really speed up the amount of time it takes to train a model. But you will still be limited by data because you scroll the whole internet, there is no more data.
Yeah.
So
I've been reading more and more point, right? Like our GPTs, like the models that we are making, the generative AI models that we're making are so data hungry that we are bound to run out of data, not in the future, but now, right? And
yeah,
we like
yeah,
mostly are running out of data. So now the idea is to create more synthetic data to feed these systems to get better.
yeah,
But if the data itself is created by AI, and then AI is being created on the same data, then I think it's a very simple terminology that we use, right? Garbage in and garbage out. So, I
yeah,
mean, where's the collapse happening? Like, how do you think like the collapse is happening here? Because I feel that, right? When
yeah,
I build a model and I try to feed it its own data, I know that's going to collapse sooner or later and start spouting out gibberish.
yeah.
As civilization, we are running out of data to feed it. So, where do you think like we are headed next?
Yeah, I think one is so initially in 2000, beyond 2012, it was more about algorithms, which algorithms perform best, or even before that, right? So we had SVM in 90s, and then neural networks, then convolutional neural networks, LSTM, RNN. We had all these different kind of models that used to work well for a different kind of problem. Like for sequences, you'll have RNNs, computer vision, CNN, and then slowly over time, and especially when transformers came in, we kind of converge to a single algorithm that does almost everything. And I think it's it's not as much about architecture currently, because I don't think transformers are special in terms of enabling reasoning or anything. They're special in terms of how efficient they are to train on large amount of data. So if we take an LSTM today and we make it as parallel as a transformer, like XLSTM kind of models, I think given the scale of data that we provide to transformers, let's say 14 trillion tokens for an LLM like Llama 3, then it will perform very similarly. So architectural changes might, well, given the current pace of AI, I think we do need new kinds of models to solve things. We do need neuro-symbolic AI kind of systems to solve things, which are hybrid. So you do need some guarantees, like okay, this is how it's going to reason in these kind of scenarios, rather than changing the answer every time you ask it slightly differently. And there are like 100 ways to solve a problem, but
The
LLMs,
better ways. It's
yeah, which is a better way? How do you self-validate? So I think reinforcement learning will play a huge role. It has already become very mainstream in large language models, etc. Uh,
yeah,
yeah,
I
I
think
think
I
we need like new algorithms to solve these problems, because yes, you can throw away a lot of data, but it doesn't solve. It's like it's a brute force way of doing things, and maybe we can reach AGI with that, maybe, right? But I still, it would still be more impressive if we can, like, there is, I don't think there's just one path to reach AGI. So there might be a set of algorithms that get the same thing done in different ways, right? So transformer scaled up to internet level data with a lot of engineering might be one way to call it like AGI in a way that we use it, but not in a theoretical sense. But there could be another algorithm that does that with like 1% of the data and is very good at skill acquisition efficiency. And I would call that to be more close to human
useful. Yeah.
level.
I mean, to be very honest, yes.
Yeah. So we might have a spectrum of models where you have like um, these are very data hungry, these are very efficient, and this is where human level
Intelligence
intelligence.
levels. Yeah.
That we might go beyond that as well, but I think will get the whole spectrum of models that can qualify for AGI in the future. Some of
I
them much
mean,
closer.
that's also how I think about it, like especially when it comes to AGI as a term, right? I
Yeah,
mean, I personally don't think there's one single definition of it. It
yeah,
means to be general intelligence. It could be from driving a car to like, taking care of my laptop to, I mean, from sales to marketing to product, everything, right? I mean, each kind of general intelligence needs to be general. So,
yeah.
I do believe in that. But actually, with that in mind, I had a question, especially when it comes to AGI as a whole, as a concept, right?
Yeah.
Uh, and also multimodality when it comes into the play. I think most of the models that people commercially use are a derivative of the GPT, like, an LLM, basically. It's an
Right.
LLM model, right? Uh, my idea and my thought process has always been along the lines of that a single kind of input will lead to a single kind of output. It can lead to multiple kinds of output as well. But as a concept, AGI only occurs when the context that is given is not just text or just image or just video or just one point of input, but
Yeah.
multiple inputs converging, getting processed, and then giving multiple kinds of output.
Yeah.
And I want to know, like, what does that look like when it comes to AI applications today, right? I
Okay.
mean, Gemini can take a video and, like, also take my voice alongside of that and then
Yeah.
have a look around and understand things. But
Yeah.
that is still not considered AGI. That's considered a good enough, I would say, object identification. So
Yeah.
when people talk about AI and when we combine this multimodality into the spectrum, what do you think is going to look like? What do you think AGI looks like?
Yeah. I think that's a difficult question to answer. Yeah, I think
I mean, according to you, right?
multimodality.
Because it's all this opinions that we discuss. So
Yeah.
what does an AGI application look like according to you? I think that'll be a better phrasing for this.
Yeah, I think if I have an algorithm that can do everything I'm doing, that can take my place in the real world and live for a month, I would call it AGI. So it can do my laundry, it can do my office work as well. It can drive a car, buy groceries, it can use a dishwasher properly, put the dishes
I
in.
can't do. I don't think that's
Like I think that is like I don't think, see, we say like human level AI is not specific to experts, right? Experts are experts in a special domain. But we do all of us agree, like we are intelligent in general, no matter what job you are doing, where you're doing, we are intelligent. So there is this Moore's paradox in AI, where things that are easier for human are much more difficult for artificial intelligence system that we are building, versus things that are more difficult for us are much easier for it. And that is quite an interesting one. So it's much easier. So people used to think initially like, oh, if you can build a model that can play chess well, that is artificial intelligence. That is artificial general intelligence. That was 1956, like the first time this.
And when AI beat humans at chess, right?
Yeah, exactly. And then after that, it was more like, oh, AI can never be creative. And then you have these large language models, like you have Sora, you have DALI, Runway, ML, etc., Stability, right? All of them are able to, well, they were trained on a lot of human provided data, but they are still creative in a sense, like you can build something creative with them, right? There was this Ghibli meme going on a few days. So we thought these things were very, very difficult for these models to do. Then we thought like, okay, coding is very difficult for these models to do. Turned out it's much easier and it's much simpler to train as well, because when you're coding something, as long as you write the test cases, you have a deterministic verifier that can verify does your code work or not, right? So it becomes very much easy for a model to be trained using reinforcement learning, where they are like, oh, okay, get to
If
basic
it does not
understanding of
work.
code, yeah, keep checking and keep improving till it passes, right? So think in terms of yeah, like in terms of providing this for the I went to a different thread.
No, no, it's completely fine. I mean, the question says was like, what do you think
Yeah,
an AGI would be capable of? I do agree with your point where yes, I've been thinking about how AI can solve math, right? I mean, that has been a question again, like, a slightly older question. And I think Kaggle
yeah,
still hosts a lot of math Olympiads, especially for AI models. Who
yeah,
wins, and I think NVIDIA wins every year. But again,
yeah,
apart from the point, I do believe that, yes, if you make a model and if it's good at one task, it's a great
yeah,
task. But if you make
yeah,
a model that is good at all the tasks, then
yeah.
it's AGI, right? And yeah, I mean,
And
I do
kind of,
believe it's a physical thing more than a it's a physical limitation, more than
uh,
I would say software implementation.
there's still research going in there. I think it's both, because currently you can't rely on that, right? You can't just train a transformer on all of the videos, all of the data, and like put it into a robot and let it interact with the environment. I mean, you can train it, but I don't think that will take you to AGI. I don't think the only limitation to AGI now is just multimodal data. I think it's more to do with reasoning, planning, execution, and then self-correction as well. And I think that's where, yeah, and again, at the end of the day, the definition that I've adopted based on what I've read so far is around skill acquisition efficiency. So I still, if I brute force something to the extent of like I trained it on the all of the data available to humanity, and now it can do something. I don't think that's AGI. But if you do that with a fraction of the data available, which is how human do, I think that I might
That's
personally
how
I might
humans, yeah.
call it AGI. Or maybe AGI is not the right term. It could be like human level AI. So
I think that
it's
as soon as we reach AGI, we change the term and then like specific one. We like generative AI, predictive AI, then we reach. But I think that
yeah,
you are right in that. If AI can learn a lot from a limited set of data, and instead of doing
yeah,
guesswork of like A means A and B means two, I think that
yeah,
that
yeah.
is
Because as a kid, like you are told like this is a dog. You are given two or three examples, and you know this is a dog, right? So you do. I don't know how brain works, but I think we do have some innateness in the brain, so that we come up with an algorithm in the brain that can learn things very quickly. That algorithm remains the same. That's why, like in your neocortex, you have the same algorithm every time, and that's why there have been research where people who can't see, they were able to see from their tongue because it has the same. Yeah, yeah. I think they were able to rewire. You can look at some videos on that as well. So,
thought
um,
about it, I'm like, oh, okay.
yeah. So there are like if there are all the regions of the brain, I think they learn in a very similar way, if not exactly the same way. It's just the connection, like this part is connected to eyes, etc. So I think if you can actually change that connection, and then you might be able to, if you can't see, you could still be able to see it. If you're connected to the other part of the brain, that can learn to do vision as well. So there is a lot of cool research happening in like brain inspired AI, or there are a few books on it as well. I think Thousand Brains is pretty nice to read into, where it says, okay, we have the old brain, I think, and then the old one, which is more, yeah, I forgot the medical term for it, lymphic, but it's more like that is more responsible for survival, emotions, and other things. And then and so that was there for million years. And then we built a neocortex, which is just a replication of the same pattern again and again, and which is where this common sense, reasoning, and all those kinds of abilities are
Communication,
residing.
the words that we speak, language. Right.
And that part looks exactly the same everywhere you see. So I think there are quite a lot of interesting research in neuroscience that's happening to figure out, okay, how brain actually works. It has some parallels in how we build AI system as well, because neural networks, brain inspired. Not exactly how it works, but yeah. There is like another paper from Sakana AI maybe 2 days ago or something, where they talk about like how neurons. So currently, every neuron is active at the same time, and they don't do much of synchronization in deep neural network. And they talked about how in brains, like there are different timing to activate certain kinds of neurons, and how they synchronize with each other. They're not treated all the same, and they're trying to build something with that, and like the initial results are pretty good. I still have to read the whole paper. It's only an abstract, but I think yeah, it is exciting to see all of it coming in.
Like, based on this, I have a very interesting, I would not call it a question, but more of an exercise for you, and something that is really fun for our readers as well as our viewers, right? Uh, so I'm sure that you have come across a lot of interesting research, interesting applications that
Yeah,
are, I would say, very technical for a layman to understand, right? Like someone who's not from a field to understand. So,
yeah,
um, why don't you explain a concept, or like explain an application or anything that is very, very, very niche to your field, but explain it so that like a normal, as you call it, like to air it, explain it to me like I'm 5 year old. So
okay,
something that, yeah, because I'll tell you. So this is something that encourages a lot of younger audience, right? The
Mhm.
graduates, the college students, uh, uh, I would say the young working professionals, to
Yeah,
take a deeper dive into the whole ecosystem. So something that is like supremely unique and supremely it's exciting for you, and then you
yeah.
explain it to me like I'm a 5 year old. Let's try that out.
Okay, I think there are a lot of research like that. I need to pick one.
I am
Okay,
all ears.
okay. Yeah, I think because large language models are very popular
Oh
currently.
yes, yes, yeah.
So that could be one to explain. I'm not sure how good I'll be explaining it in layman terms, because yep, I have a very different kind of background, but I can give it a try. So I think generally, okay, large language models is a concept that is from, well, language models is a concept that has been there from 1950s. I think Shannon first described it as a language. Yeah, 1950. They didn't have the computing resources. A lot of the deep learning breakthroughs
Mhm.
are product of the past, with obviously great increment that we have done recently, but the foundation is like 28 years old. So language models have been there for so long. Now the idea there was, in general, like, okay, how do you learn a language in general, right? Well, what does it mean to learn a language? So I as a human, would go through, let's say I'll read books, I'll talk to the teacher, they might explain this is how it works. I will try to talk to people in that language, make mistakes, learn from my mistake, etc. Kind of like a feedback loop, where you pick up something, you make mistakes, you learn from a mistake, you improve, right? Which is how most of the machine learning models work in general. The idea there was, can we do the same for a language? Because language is so diverse. It has so many ways to say the same thing. So anything, yeah. If you just look at, okay, if you say he, next word should be is, and so on, then this will not work. This cannot work, right? Generally speaking, but the magic there is like it does. So you take a lot of data, like whole of the internet, all of the books that are ever written, all of the newspaper, etc. Right? All the text that is available in the world, and you train a simple model with obviously a large enough parameter, but you take a simple model and you just try to predict the next token. Like if it is his, then it is. If it is she, it is. If it is you, like it will, etc. Right? So you have all of these sentences. So on paper, it looks like all you will learn is when this word appear, this should be the next word,
Like
right?
keyboard used to do, right? Like if you type this, then this is what you like type next.
Exactly. So this looks like a simple if-else kind of situation. He appears 10,000 times in my text, and next word is appeared 1,000 times after it. So there's 10% probability that is
That
the
the
next
next word
word.
will be it. Yeah.
So that's how it feels like. But when you train the same model, don't change anything else for like millions or trillions of tokens. I think it actually results in something like ChatGPT. And then you can see like it's not predicting just it is still predicting the next token given some first word or second word or like a set of sequences, but it has not learned just the correlations in a way that we talked about it. Like it hasn't learned if this word appeared, then this word should appear next. It has learned slightly more than that, kind of like uh, the intent behind speaking something. So how we like creating a world like a real world inside it. Well, I won't say real, creating a world model inside it, even though it's not perfect. I think that is something like that still feels like magic. Like how can this happen? Because
Yeah, it's like
I have 100
I've
examples.
heard this analogy.
Yeah, because if I have 100 examples, all I get is correlation. If I have 1,000 examples, all I get is correlation. If I have 1 trillion examples, I get something like ChatGPT that can just talk to me in whatever language, give me useful responses. So, yeah, I think that's
It's not by the way, like like till that 99%, it is gibberish.
yeah.
It's just correlation, and that like as soon as the 100%, like so, what's the threshold? What's the number of? It's a
I
number of
don't know.
tokens, right?
I don't know. I think there are two things. So one is how much data you train these models on, and another
Yes.
is the number of parameters. So obviously, like in the hindsight, it seems obvious you need a large enough model to be able to memorize important concept, to be able to generalize based on those concepts. So I cannot, if I have just 100 parameters, I cannot expect the model to learn everything about a real world with 100 parameters, right? So I need at least thousands, millions, or billions. It turned out like that is true. So in the hindsight, it looks like, oh yeah, that is obvious. Like you need capacity to learn first so that you can learn and then generalize better, right? If your capacity to learn is very small, then you cannot. But yeah, when Ilyas Utskiver, etc., when they made this assumption like, oh yeah, scaling things will improve, things in 2016, 17, that was very new at that point and wasn't at all obvious. Like, oh yeah, just scaling the model will give you all of these different capabilities. So it's
Yeah,
more of an
it's still like to understand, right? Like you just take a model and you just keep feeding on data, and then one point it's like I'm awake. Now
yeah,
I can
yeah,
talk.
exactly. Yeah.
Uh,
So that's still like I try to explain it, but that still feels like magic to me.
yeah,
And
no, I think
like
that's true. By the way, I'm so sorry because like we generally like take a 45 minute show, right? So it's 40,
uh,
and I have 5 minutes to ask you three very important questions. Okay. So like I
okay,
said,
yeah,
uh, so the podcast is like it's heard by a lot of young viewers. It's read by a lot of key decision makers at organization. So it has a
yeah,
very wide target audience. Now,
yeah,
so at the end of the podcast, I always take three questions. So it's just sort of my thing, right? So one,
okay,
I would take that is directly relevant to the younger audience, right? One I'll take that is directly relevant to the organization. And the third one
yeah,
I'll take that is directly relevant to something that you just wanted to share to the world with a mic, like in your hands. So like, like a
okay,
message to the world. So my first question, my first question is for the younger audience, right? So like slightly younger audience, I would say the working professionals, people who just started working today. As a person who has changed field, so spending like, like you said, like almost a quarter of your life what
Yeah.
kind of an advice would you like to give to someone who is starting their career today in the field of AI? What do you think they should prepare for? What do you think they should be okay with letting go? And like, what's your general like rule of thumb that you follow that has helped you so far in
Okay.
your career?
Okay. So I think good question. So I would say it's the best and the worst time to learn things. Because we have a lot of information, and then you get an information fog, and it's like you're always in this eternal student syndrome kind of a situation where you go from courses to courses, projects to projects, training models on MNIST, etc. again and again. So don't fall into that. Learn to leverage the tools that are present today, right? So you can just go to Google AI Studio and you can just use their latest model for free as much as you want. And you can take LLM's help in general to come up with a schedule that works for you, how to learn things, etc. But foundations are more important than ever today. So I would say like use these tools for guidance, advisory, maybe coaching as well. I use it for coaching as well. I keep daily notes, what I want to do, what are my daily, weekly, monthly, yearly goals. And then I built a connector with an LLM that critiques me every day. I've asked it to be strict. Then it just goes through my notes. It's like, your notes are not detailed. So what are you doing? This is just a wasted day. You didn't do anything. You watched a movie rather. So I think you can use these models in a way that can help you learn better. Foundations are more important because I think of it as a game. So imagine you start playing a game and AI as a cheat code, so you're suddenly at level 70 and you're very happy. But so it can take you from 0 to 70 in an instant, but 70 to 100 you have to do yourself, right? Now, if you have never played the game before you use the cheat code, then if you can't use it anymore, or if it is not reliable enough, then it just becomes very, very difficult for you to go from 70 to 71, 75, 80. So foundations are very, very important. So I think spend some time building things, reading things, read a lot of the current research paper. Don't fall into the AI hype because not every day is not a breakthrough in general. The the papers, the ideas, etc. that are important will stick anyway and come your way if it. So yeah, build a good foundation and start leveraging these tools because I don't think they're going anywhere. Um, just need to learn to how to use them well in different ways.
Shall like similarly, what is your advice to organizations? So I'll be very honest, and this is a question that a lot of folks are like, hey, why should I give like advice to organizations? But the way things are changing, a lot of organizations are like I would say some of them are too fast. Where they're like, okay, like, this is new, I want to try this. This is new, I want to try this. And a lot of
Yeah,
organizations are like, hey, we'll wait the hype down, let things calm down, settle down, and then we'll move. And I feel that both of them are like not the right, not the wrong answer, but there has to be a
yeah.
midway, right? So, what are your thoughts? How do you think the changing world should be adapted to by organizations? And what
Yeah,
should they be on the lookout for? Yeah.
yeah. Good point. So there is a trade-off. So you don't want to be stuck in the past, but you also don't want to go too fast that you just break things and it doesn't work. So I would say like you need to be in a space of cautious experimentation, depending on depending on which field you are in, right? So you do want to build POCs. Let's say if you take generative AI as an example, you do want to experiment and build POCs, do hackathons, etc., to see what's possible. But this is just one tool, and once you start thinking about productionizing things always break. So it's just one tool in your whole pipeline, right? So you need to focus on like rather than using AI as a hammer to see, okay, I know generative AI can do these things, so let's just put it somewhere and see what works. You need to work on the core business problem that you want to solve. So identify the problem first that you want to solve. Create a baseline in general based on what's available rather than going for the AI hype directly. And slowly experiment and integrate AI into your workflows in general, I would say. But yeah, rather than going the other way around, where okay, I know generative AI is there, we have access to it. So let's see where.
Just like, start putting it everywhere and see what sticks.
Yeah, and I think the best use of generative AI that I have seen so far is converting unstructured data to structured data. Like I would explain it this way. So you can create data sets that were never created before to solve problems that you were not able to solve before in general. So it's like if you want to know, let's say if you want to build company researcher or something, right? So you can search for that company name on Google, summarize it with an LLM, and that will give you a data set of what this company does. Of course, you cannot always rely on it, but that you can pass it through machine learning models to see to get out.
Someday it'll be great. So, yeah.
Yeah, but then the other way to solve that problem is you can go to the registry, company registry, and get the information from there as well.
Yeah.
And then you can combine both information to come up with a data set that never existed before for your specific needs. And, so yeah, I think focus on that. I think, and again, like data is the key. Like the however good the data is, that's how good the model is going to be. So even though you can build text to SQL very quickly on a very simple data set or Chinook data set in general and get real good results on benchmarks, you start putting it into your production pipeline, it's going to break. It will take you months to solve it. It took like Uber to reach around 75% accuracy in text to SQL, 2 years. It took them 2 years to reach that level. Obviously, the LLMs were improving at that time as well, and they are much more mature. But you'll encounter all different kinds of problems once you start production and things. So really focus on the problem you want to solve that is core to your business, and you start leveraging these tools as it is. Yeah.
That has been great. Now I will ask you the last and I would say the hardest question, right? Because again, this is more of a personal art that I've had. Okay, where a lot of folks have a lot of interesting things to say, but they never get enough chance to tell it out. And I mean, for me, it was my core values, like things that I work with, whether it's in my life or whether it's like other way around. So, what would be that one message that you'd want to share to the world as a general? And it sounds abstract, but could be for younger audience, could be for
Yeah.
someone who's new to this field, could be for organizations, could be for me, even do better podcasts with me. But
Yeah,
but
you have
like,
been
what
great.
was the one question that you have, or that one thing that you want to share to the
Yeah,
one that I put in the footnote of the written blog?
interesting. Yeah, I wish I had more time to think about it. In general, I think, yeah. So there are people have a lot of ideas in general, but they don't always act on it. But today, it couldn't be much easier than in the past. And every day it becomes even easier to act on your ideas in general. So don't get so this is an advice for me as well. Don't get distracted by too many ideas. Just start building, and things have never been easier to build than like leveraging these AI tools, etc. So like I used to keep an idea registry. Oh, I'll work on these ideas, like 40, 50 ideas written down and nothing ever worked on. So it's like you find a problem that you are interested in. So if I'm playing tennis, I might use computer vision to build a tennis match analyzer. If I'm let's say playing guitar, but I cannot let's say I cannot read sheet music. You might train a model to convert sheet music to tabs because I can read tabs are much easier. If I'm taking notes, I can use that as a coach. So yeah, I think these are things to improve your personal life in general. And then if you have other ideas, just go ahead and build it. If you are worried about startup, etc., it open source, get some traction, and maybe build from there as well. But keep building and don't just passively read things. And on contrary to that, do read a lot of books. That helps.
You're the third person on this podcast, and I've done only six. You're the third person who has said, in a way, like, an interpretation of the line that this now is the greatest time or the best time to build things. It's
Okay.
the easiest, it's the fastest, and the most,
Yeah.
like, you now have access to things, right? And yeah, I mean, it's a nice topic. I love to do this. But yes, Tara, I mean, it's been great to have you here. I've been very, this is one of the best conversations that I've had in such a long time. Talked about some very interesting topics. I hope
Thank
that I was able to do justice to all the things that you've done. Obviously, would love to connect once again to maybe discuss more about your work, things that you do at NatWest. I don't think I covered that topic as a whole, right? But
Yeah, yeah.
yeah, I mean, like the rule of thumb, right? Like this is an ongoing series, and would love to host you more and more often. The idea behind these podcasts, these interviews, is so that you also have more and more content that goes out in your name, so more people are able to understand and know about you, right, about what you do, and give you the visibility across. And same to get more and more people interested in getting from physics graduates to data science to learning AI, right? So yeah, I mean that has been the idea, and like honestly, it's been great, Sharad. And yeah, anything that you'd like to add to me, like you know?
No, I think that's mostly it. But thanks for having me. It was a great conversation. Great questions as well. I might write back some of them later on if I come up with a better answer. But hopefully,
Just let us know. We'll edit on the blog, right?
okay.
Uh,
All right.
no worries, but yeah, thank you so much, man. And yeah, have a lovely day, man.
Yes.
Bye bye.
Nice. Bye.
Bye bye.